Caching și pe technical difficulties a LangGraph Studio. Il fa min piaciuto bitoma si cavolo.
Hey everybody, can you hear me? Say hello over the chat. If you can hear me, say hello. All right, good. So welcome to another event of DevFest. Today I have with me Atai. He's in the room, but he will join very soon. He's
Hello,
going
everybody.
to you. He's already here. So say hello to everybody.
Hi, everybody. I'm Atai, co-founder and CEO of Copilot, and looking forward to a session today.
Great. So 2 days ago, we talked about Copilot Kit and how to use their React component application. Today, we're going to talk about agents, and Atai will explain more further like what is an agent and how you can use it to automate different things. Before I'm giving the mic to Atai, I'm just starting the giveaway. So let me give you all the link. One moment. So just join in the link. I'm popping it up in the chat. Register, add your GitHub handle, and that's it. And I will prompt it a few times more during the event. So have fun, everybody. And Atai, the floor is yours.
All right, everybody. Great to be here. And thank you, Nicole. So in your previous session, you guys went through one-shot copilots. Now, these can be extremely powerful. But oftentimes, as you keep building, you really want to have more control for richer agentic systems. Now, over the last year or so, the dominant pattern that has emerged for designing agents is graphs. So in this session, we're going to explore a graph-based agent that is based on LangGraph that uses Copilot's new co-agent infrastructure to be deeply integrated into an application. So before we begin, let me actually just run the demo and show you what the end result will look like. So 1 second, let me know if you can see my screen. I think it might be locked. Oh, never mind. Okay. Can you guys see my screen there? Can't see the chat. Can you guys see the screen?
There is usually a slight delay between the chat and because it's like streaming. So it might take them like something like 10, 20 seconds to
I see. Can you see the screen, Nebo?
No.
No. I see it on my end. Do I need to do anything to switch the source?
I see it. Okay. Here. Now
you see it? Okay. All right. Great. So this is the end result of what we're going to be building. So first we're going to look at that, and then we're going to look at how we actually build this. So this is a Perplexity clone of sorts. If you're familiar with Perplexity, it's a agentic search for the web. And so here we have a AI research agent that can search the web for us and answer questions for us. So let's say we click on this one. We can also just write whatever question we want, but let's say we click on one of the pre-loaded questions. Electric cars sold in 2024 versus 2023. So you see that in order to answer this query, it decided on a number of sub-queries that it should go and answer. So search the web for electric cars sold in 2023, and also same for 2024. And one for comparing the electric cars to determine the difference or the trend. So that's interesting. That's a separate thing. And you can see that each query here, you also see what is going on with it, not just the fact that it was made. So before it was querying the web, now it's extracting information from the web results. Now that it's done that, it's extracting the answers. And we will see here in a moment too, also the references. And each one of these is actually its own native application UX component, right? This is not just chat UI. So this is how it works. Now, this is the end result. Now let's dig in and see how we actually build this. And this is really something that took us literally a few hours to build end to end, everything included. And so it's very straightforward using co-agents and the ecosystem. All right, so let me share a different screen now. Let me just share my entire screen. I think it'll be easier. All right. So here we have LangGraph Studio. So this research agent is backed on the backend, on the agentic backend side, by a research agent. Now you can see here the steps of the agent. If you've worked with LangGraph before, you know that essentially you build the flow diagram of what the agent does when it does the work. So you see here we have the start node, which gets the input of the user query. The next node is the steps node. So this is the node that decides to break down the original query in the original question into a number of steps, a number of sub web queries to be looked at. The next node here is the search node. So for each query we decide to do, we go and actually search the web, and we use Tavily AI for that, which is essentially search engine for AI agents. Now, after we search, we extract the information right from each node. Okay, there's the search result, but you actually want to go and extract the information there, see what's relevant. Finally, you want to summarize everything into a single text and references file. And then finally, you're done. So let's actually run through this. This is LangGraph Studio. This is kind of a IDE for agents. So let's do a query here. Again, we can do the same thing. So, cars sold 2023 versus 2024. We had electric cars. So we submit this query, and you can see what's happening here. It's going through the nodes. You can see the data that flows through here. So the steps that were figured out here is search for number 24 and number 23. This time there was no third query. There's the search message. Now it's extracting information, right? It's going one by one and finally summarizing it. If we scroll down here, so you see the summarization and the references as well. Here they are. So here you saw the node, the agent actually running. Now let's actually dig into the code and see how you actually can build something of this yourself. And by the way, everything here is open source. Copilot itself is open source, and so is this example. So you can go to our repo and look at the examples folder, and you see the co-agents AI researcher, and you can check this out yourself. So we have two components here of this agent. We have the agentic side, we have the application side. So let's first just look at the agentic side. So on the agentic side, we have this agent.py file, which is straight, normal, standard LangGraph agent. So those of you who've used LangGraph, you know that essentially, the agent that we saw here, you basically build this in code. So you say which node do you start from, what are the relations between nodes. So you add these conditional edges, and all this is pretty straightforward. So you can dig in here for each individual node and see how that works. For example, this is a search node. It has a Tavily tool that it is calling. But that's essentially how that works. So pretty straightforward. Now, we also have this demo.py file here. And this is the only part where you have Copilot specific code with a small asterisk that we'll get to in a minute. But essentially, all you need to do to serve a LangGraph agent to an application is you create this fast API, standard fast API backend.
Hi, do you think you can enlarge the font a little bit?
Yes, thanks for the note, Nabo. How is this?
Yeah, I think it's much better.
All right, great. Yeah, so we create this fast API backend, and then we use the Copilot SDK to create a Copilot specific endpoint for this. So when we create it, all we have to do is initialize an array of agents. Each LangGraph agent gets the name of the agent, which will be used to identify uniquely, a description, what this agent is used for, and then finally just the graph object, the standard LangGraph graph object that we created before. So nothing at all that is specific to CopilotKit. And by the way, you can see here that an application can have more than just one agent, right? You can have 1, 2, you can have 10 agents, can have more than that as well. So that's another good way to structure an application, is to create essentially agents that are specific to specific skills that you want to accommodate in your application, and essentially route the right question to the right agent at the right time, which CopilotKit takes care of. So this is on the agentic side. Now on the other side of the Python side, first you have an application. How does it even know that it's connected to CopilotKit, right? The first thing you do is you wrap your application in a CopilotKit provider. This CopilotKit provider has, in this case, a runtime URL. We also have a cloud hosting that you could use, Copilot Cloud. In this case, we're using the open source self-hosted runtime, so that this example is self-contained. And which I will show it to you in a minute. It's very straightforward to set up. And then finally, in this case, we're locking the CopilotKit to one specific agent. So I mentioned before, there's a number of ways you can run Copilots. You can have route things to the right agent at the right time, and you can use a combination of agents and one-off React loops. In this case, just for simplicity's sake, we lock it to a single agent. So now, how do you set up a Copilot runtime? This is all there is to it. There's really nothing here, almost no code at all. We create, in this case, a Next.js API endpoint. We specify the URL of the remote backend, remote action, which is what we have the Fast API service that's running. In this case, we're using OpenAI as our LLM adapter. So that's really just essentially boilerplate to get started. So now at this point, you have an application that is connected to Copilot that is itself has access to this remote Fast API that runs LangGraph agents. So this is now our starting point. Okay, so now it's connected. How do you actually use all this information? And you will see that it's actually extremely straightforward. So we have a number of React hooks that are available here. The one that is key in this case is use co-agent. Use co-agent gives you access, you see here, to the state of the agent. So we saw before here that the agent, just like a normal chatbot, has this abstraction of messages that get sent, right? But unlike a standard chatbot, the agent also has an actual structured state, much like a normal computer program. And so in this state is what stores the structured information of the agent. So we, just by using this React hook here, use co-agent, we get access to this state object as it's streaming. Now I've got here this console.log that shows it's printing the agent state as it's going along. So you can see here that as the agent state is changing, every time it changes at all, we get an updated state here, which is really great for working with React applications, so really React Native build application. And then, once you have the agent state, you can probably, you guys, see how you would use that to create, the application native UX. So this is not what we're gathering for, so we don't have to zoom in on this too much. It's standard React application, uses Tailwind for visualizations and all that for styling. And that's essentially it in this case. Right now, there's the question of what are the components of a co-agent. And if you go to our documentation, you will see here the 4 key features of a co-agent. So one feature, that's what we just looked at, is streaming the agent state. And if you want the agent to work alongside a person, you can't have the person there just sitting and looking at a spinning wheel for 30 seconds or 20 seconds. That's looks like a broken product. So first step, as basically as it sounds, is just streaming the agent state as it's happening. And we saw that we did that. And actually, it does remind me that I forgot to cover the only one thing you do need to do on the agentic side in order to support this streaming agent state. So let me, before we move on to other parts of coagents, just quickly find that. So here it is. So this is the only piece of code here that is actually specific to CopilotKit is this CopilotKit customized config. LangGraph agents, every single node in a LangGraph agent gets as input the state of the agent when it enters this node and a LangChain LangGraph config object. Now, generally, the state of an agent only changes between nodes, right? When you finish the node, that's when you return the new state of the agent. But that would be if that we only updated the state on the front end at the end of each node, it would be very abrupt changes. And that's not what we want. We want to actually stream these changes as they occur in order to keep the user engaged. And so the only thing you need to do to support that is call this CopilotKit customized config call. You pass the original config, and then we pass here a configuration of how to emit intermediate state. So we pass here what is the key in the state object that we want to modify as a result of calling which tool, and specifically which argument on this tool. And so in this case, we look at the tool argument and the tool call, the search tool call, look at the steps argument, and we treat that as state object of the agent state. And CopilotKit takes care of all the synchronization that needs to take care here. So when the agent state finally does, when the node does it finally finish, everything gets synced up. So this is streaming the agent intermediate state. There's other features that are core to a co-agent. One of them is generative UI, right? You oftentimes want to actually visualize what the agent is doing here in the chat window, if you do have a chat window in your application. So CopilotKit makes that also very straightforward to do. I won't dig into this too much here, but you can check it out in our documentation. There is shared agent state, which is actually also very critical. So in the example from before, the use co-agent example, we read the state of the agent. There's another variable that's available here, which is the set state, and another function call that's available to us. So that allows you to get an application where the end user, the human, and the agent collaborate over the same state, which is extremely powerful pattern. So this is shared agent state. There is agent Q&A. So the agent can actually pause and ask the user questions and wait for an answer before returning. And then one more feature that is not yet mentioned here that is in the works is agent steering, which is, as agents do their work, sometimes they might have a mistake somewhere along the line. If they have such a mistake, everything that comes afterwards is not going to be useful. So agent steering allows the human to notice, hey, there's a mistake here in step 4 out of 9, let's say. Instead of throwing away the entire thing, let's just zoom in on step 4, fix the error, and then move forward. And that uses LangGraph's time travel capabilities of the agentic backend side and creates front-end infrastructure for connecting this to an actual application, an actual user. And so, yeah, that's the essence of coagents, and happy to take any questions. Nivo, are you guys with me? Can I get confirmation? Here's no.
Yeah, I'm with you. And just usually there is a slight delay between the chat and everybody, so I'm looking for the questions over the chat. Let's wait a few moments. See if somebody have a question.
I actually lost the chat. Can't see the chat anymore. Oh, there we go. I see it again.
Are these features completely free to use? Somebody else.
Yes, these features are part of the open source part of CopilotKit. So CopilotKit has the core of CopilotKit is open source, and everything that is in open source is free to use. And then we have Copilot Cloud, which is a complementary cloud native platform that complements the open source part of CopilotKit. And over there, we also have freemium, so free to start model.
Maybe I will ask some question until people come up with some questions. How did you connect the agent to the CopilotKit chat?
Yeah, so here, let me share my screen here again. Can you see my screen?
Yeah.
All right, great. So we essentially have the two sides here, the agent side, which is a fast API server that is running. And you can see I am actually running it here. So if I quit here, I run Poetry Run demo, and now this fast API is running at this URL, port 8000, as you can see here. And it is serving on this /CopilotKit endpoint, sub endpoint, a CopilotKit compatible server, essentially. And this server serves now a number of agents, in this case, just a single agent, which is the search agent. So now we have this server running on the Fast API on the backend, on the Python side. And on the front-end application, we have, first of all, here, this CopilotKit provider that is pointing at /API/CopilotKit, which, if you guys are familiar with Next.js, this is a Next.js application, is what's available, is the route that is defined under app API CopilotKit, which is right here. You can see here that we are initializing a Copilot runtime object and passing to it a remote action with a URL. And so there's the base URL, which is exactly what we saw before. And then we do /CopilotKit. So you see, it's exactly what we have running here on the Python side. So now the application is connected to a CopilotKit provider, which is itself connected to this remote Python server.
Cool. And another question is, last day I showed everybody how to make like an entire to-do. And then with CopilotKit automated, add new to-dos, remove to-dos, complete to-dos, and so on. What added functionality, for example, I could do if I added the LangGraph to it in agents, for example?
Yeah, great question. So all of the standard CopilotKit features continue to work when you use LangGraph agents. So if you remember from the previous demo, the core abstractions that you were using are, and maybe you can even come here and pull them up. Let's say we did this here, was use Copilot action, right? And use Copilot readable. Copilot action exposes application actions to the Copilot engine. And Copilot readable provides information from the application to the Copilot system. So both of these things continue to apply. So every single action that you expose to the Copilot engine is also made available to the LangGraph agent. So that LangGraph agent can now call these front-end defined actions extremely easily. And it's actually not just front-end actions, but all of the, there's back-end actions available. And also, as you guys saw now, there's also remote back-end actions that are available. So you can define actions across different servers and have everything work together seamlessly. And so that's on the action side, and same on the readable side. On the readable side, every piece of information that you expose to the Copilot is available as under a special CopilotKit sub-state on the agentic state object. And so, yeah, you can continue to use everything from the standard CopilotKit object. And so essentially where the agent would come in is if you knew that there's, let's say there's specific types of, that's actually, it's a good question. I want to maybe zoom out a little bit more. If we even forget for a moment the example of the to-dos, we go back to this research agent. You see here that we are predefining what being a research agent means. We say every time there's a research query, we break it down to substeps, we search the web for each substep, we extract the node for each one, finally we summarize. So we really put the agent on guardrails. We constrain what it's doing. Now, we didn't have to do this, right? We could have just allowed it, given a tool to search the web. We could have allowed the LLM system to decide, hey, you know what? Now I'm going to summarize everything and return it. So we could have left all of this open to the agent to do. Now, the thing is, in principle, that would be great, right? Everything much less work for us. But in practice, when you give agents too much freedom, they tend to just fail. They tend to totally burn. And that's where human in the loop comes in. And so there's two kind of branches of human in the loop. There's build time human in the loop and runtime human loop. What we see here, this is build time human in the loop. We're constraining the agent to do specific things that we know are going to be needed to be done many, 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 many times in the context of our application. We know our application. And so we do this here. You can imagine this getting more and more sophisticated, right? Maybe you're creating an agent that is a legal assistant, and you know there's a specific legal process that you take that you have to go through every single time. Now, you want the LLM intelligence to help you there, but you don't want it to start from scratch. You want it to be constrained to a single system process. So this is build time human in the loop. And then the thing is, even when you do that, agents still don't tend to work well enough, which is why you need this runtime human in the loop controls to allow the agents and the human to work side by side rather than autonomously. And that's where CopilotKit really comes in. And so in the context of the to-do example, you might know that in your application, maybe your to-dos are to-dos for engineers who are building features. So when you create a to-do, you know that you want to go through specific substeps that are maybe try to figure out what are engineering tasks they want, maybe what are people you should check up with, maybe this is design related, maybe this is QA related. And so you can build these things into your agentic flow. And that's the cases where you would want to use agents versus using the built-in React looped as is.
I want to extend into that and maybe a little bit like simplified it in like dumb terms. So
Yeah.
First of all, I created with you last time the to-do list. And the to-do usually works really straightforward. You write something, ChatGPT get the answer, and then return the output. But nothing happens in the background. Every time we have a request, go to the backend, get it back, and that's it. But what happens if I want the request to go to, because we created the to-do list, and I want to go to my calendar, fetch all the stuff from my calendar, and then fill up the to-do list? You can do that with a simple chat. You have to do some things in the background. Those things in the backgrounds are basically your agent that go and do all this stuff. So basically, when you write a prompt, and this is why it's called human in the loop, you can kind of like take the prompt in the middle, do different stuff if you detect this is the prompt, and then return a better data for the user, not only what they have on the page. So it's just like to really simplify this entire process. And there is like so many other things. And, sometimes you want to do multiple things. So you want to stream information. So you need to go to your calendar, but you also want to go to your Google Drive. You also want to go to your whatever Instagram to fetch up the latest trips that you have. Each one is a task. And then you need to inform your client every time that you finish this task and move to the next task and finish and move to the next task. This is really cool. Atay, would there be a way to use it also in the future with the JavaScript?
Yes. So LangGraph has LangGraph Python and LangGraph JavaScript. And the initial support is for LangGraph Python, but very soon we're going to support LangGraph Cloud as well, which actually will make it agnostic to to JavaScript and any other platform that LangGraph will be supported on. Yeah.
Okay, somebody asked if we can demonstrate this idea, but I think it will take too much time if we try to.
The to-dos and the calendars.
Yeah, with the calendar and stuff.
Right.
Too much time.
Yeah.
But we might create like a different demo for you after the event and show you how it works.
Right. Yeah, no, it sounds like a good idea for them, to be honest.
All right, cool. So I think we are in the end. Let's do the giveaway. Atay, thank you so much. That was like super insightful, and I'm sure people will find so much usage for this thing, especially because it's free and everybody can use it. So thank you so much for that.
Thanks for having me.
All right, so I'm going to let me now take all the winners. Okay, put it there. Okay, let me share with you. All right, so I added everybody here. We're going to run the Wheel of Fortune. So can you guys see my screen? Let me even enlarge it a little bit. Just tell me yes, so I know everything is okay. All right, so let's pin it. Rashamad, are you here with us in the chat? Rashamad? Ahmed Rais, is that you? You are Rashamad? Let me see. All right, cool. So he's here. Second. Like if I see you two times, like when I spin the wheel, I will see that you have two like duplicated result. I will just disqualify both of the results. All right, next one. All right, Varsha Jan 4451. Are you here with us? Varsha Jan, are you here with us? Okay, he's here. Let me see that you don't have any duplicate. All right, he's the only one. Okay, thank you, everybody. So basically, just to repeat, by the end of the event of DevFest, not this event, the winners will have a special way to claim their prizes. They will literally have it inside the DevFest system. They'll just need to fill the form with all their shipment details, and we'll just send it to you. So that's it from our side. If you have more questions, feel free to ask them on Discord. Thank you so much, and I'll see you next week with our new events. So bye-bye, everybody.